Rate limits are an important part of working with LLM APIs. When our application sends requests to an AI server, it cannot always send an unlimited number of requests at once. The API provider controls how quickly those requests can pass through. Think of it like a traffic control system. Requests that are within the allowed limit can continue to the server. But if too many requests arrive in a short period of time, some may be temporarily blocked. This helps protect the API, prevent overload, and keep the service stable for everyone. These restrictions are known as rate limits. A rate limit controls how many requests an application can send within a specific period of time. Imagine many API requests arriving at the same time. Before those requests reach the LLM server, they pass through a gateway. The gateway checks how many requests have already been sent. If the application is still within its allowed limit, the request can continue. But when too many requests arrive too quickly, additional requests may be temporarily rejected. This helps the API control traffic and protect the server from becoming overloaded. Why do LLM APIs need rate limits? LLM APIs require a large amount of computing power to process requests. Imagine thousands of applications sending requests to the same AI servers at the same time. Without limits, a single application could send a huge number of requests and consume too many resources. Rate limits help control this traffic. They help prevent abuse, protect the infrastructure, maintain service stability, and share computing resources fairly between users. This allows the API to provide a more reliable service for everyone. Let's look at a simple example. Imagine an LLM API allows 100 requests per minute. Your application starts sending requests. Request 1 is accepted, request 2 is accepted, and the requests continue successfully, all the way up to request 100. But then, the application sends request 101. This request exceeds the allowed rate limit, so the API may temporarily reject it. After enough time passes, or the limit resets, the application can continue sending requests again. Now let's look at the rate limit workflow. First, your application sends a request to the LLM API. Before processing the request, the API checks the current rate limit. If the request is within the allowed limit, it continues to the AI model. The model processes the request and returns a response. But if the application has already reached its limit, the request may be rejected. The application should then wait before trying again. This simple process helps the API control traffic and keep the service stable. LLM APIs can use different types of rate limits. One common limit is requests per minute, or RPM. This controls how many requests your application can send within 1 minute. Another limit is requests per day, or RPD. This controls the number of requests allowed during a full day. LLM APIs may also use tokens per minute, or TPM. This controls how many tokens can be processed within 1 minute. So when working with an LLM API, we need to pay attention to both the number of requests and the number of tokens being used. Let's look more closely at requests per minute, or RPM. RPM controls how many API requests your application can send within 1 minute. For example, imagine the API allows 60 requests per minute. As your application sends requests, the API keeps track of how many have been used. If you stay within the limit, the requests continue to the AI model for processing. But if you send too many requests before the minute is over, additional requests may be temporarily rejected. Once enough time has passed, your application can continue sending requests again. Another important rate limit is tokens per minute, or TPM. LLM APIs process text using tokens. Every prompt you send uses tokens, and the generated response also uses tokens. For example, an API might allow 100,000 tokens per minute. Even if your application sends only a small number of requests, those requests could contain very large prompts or generate long responses. In that case, you may reach the token limit before reaching the request limit. So remember, requests per minute and tokens per minute are two different limits. It is important to understand the difference between requests and tokens. An application can send many small requests, with each request using only a few tokens. Another application might send only a few requests, but each request could contain thousands of tokens. So fewer requests does not always mean lower API usage. You may stay within your request limit, but still exceed your token limit. That is why LLM providers often monitor both request count and token usage separately. What happens when you exceed a rate limit? The API may reject your request and return an error. One of the most common responses is HTTP 429, too many requests. This usually means your application has sent too many requests within the allowed period. When this happens, your application should not keep sending requests immediately. Instead, it should wait for a short period of time and then try again. Remember this important status code. 429 means too many requests. It is important not to confuse a rate limit error with an authentication error. A 401 unauthorized error usually means there is a problem with authentication. For example, your API key may be missing, invalid, or incorrect. A 429 too many requests error is different. It usually means your application has reached a rate or usage limit. So remember, 401 means check your authentication. 429 means check your API usage and rate limits. Rate limits and quotas are related, but they are not the same thing. A rate limit controls how quickly your application can use the API. For example, you might be allowed to send 100 requests per minute. A quota controls how much total usage is available over a longer period. A simple way to remember the difference is, rate limit is like a speed limit. It controls how fast you can go. Quota is like your total usage allowance. It controls how much you can use. Understanding this difference is important when managing LLM API usage.